Okay, good morning, everyone. Uh, my apologies for the late start. I broke something in my setup late last night and didn't notice until this morning, so I had to come in and try and fix that very fast. So I do believe I've got that working now, um, but I suppose we will see momentarily. I'll get started in just a minute if someone could let me know that my audio is going through correctly. Just for everyone's information, we have posted on the channel 2 new YouTube videos. One of which is an introductory video that tells you all of the things that you'll need to get set up for today's session as well as Monday's session should you decide to join that one. And then Jed has recently posted another video talking about some of the review examples for the if statements as well as the Pong game developed. So if you're interested in that, please do go check it out. Otherwise, I'm already a few minutes late, so I think I will get started here. So, good morning, everyone. Today is session 4 of Schulich Ignite program. This is the first session we're running online, as I'm sure you're all well aware. We are getting used to the new setup, so I do hope that you'll all be patient with our inevitable technical issues that we will face. We've already encountered some of them. We ran a test session last week, and hopefully that will have caught some of the technical issues we'll face, but there will definitely be others. So you have our apologies for that, but there's only so much we can do. Anyway, let's get started on today's session. So today we're going to talk about if, elif, and else, which we talked about last session a couple weeks ago. So we'll just go over that again just to make sure everybody has a solid understanding of that. We'll review logical expressions, and then we're going to start talking about today's new content, which is lists and loops, and this is where programming really gets exciting. And also sometimes hard to follow, but mostly the exciting bit. One thing I do want to note to mentors and mentees alike is if you have commentary or questions that you'd like to ask within kind of yourselves that I don't need to see, please ask those on the Discord server. If there's something that you think I need to see, whether it's with regards to technical issues for the stream or simply because you have a question that you think you'd like me to answer, I would appreciate it if you could post that in the YouTube live chat, which should be working, just because it's much easier for me to monitor only one thing than trying to look at both Discord and YouTube. Okay, the other thing I do want to mention is that if you have not already gotten processing set up, you should go have a look at the video that I posted last night. That does have a section later in the video at about 6 minutes, if I recall correctly, that goes over how to install processing. And then you should rejoin us. So with those out of the way, let's start our review of if, else, and elif. So if, elif, else is a programming kind of syntax and setup that lets us run one piece of code instead of any other piece of code. So we can see here on screen this particular example. So if mouse y is greater than 500 corresponds to us being in, actually the comment there is wrong. That's actually if we're in the bottom half of the screen, which you can see. I think it's just the on-screen code is wrong. Our apologies again on that. But if mouse y is less than 500, which corresponds to us being in the top half of the screen, then we'll fill it with red. Else if, or elif, mouse x is less than 500. So that only checks after it, oh, can't see the animation. Behind me. Problematic. One moment. Thank you, Richard. There we go. Animation. So, in the top half of the screen, it is red because that first statement is checked. The mouse is in the top half of the screen, and it then jumps all the way from that top line down to the line that says circle. If that's not true, if it's not in the top half of the screen, it then checks to see if mouse X is less than 500, so if it's in the lower left half of the screen. If that's the case, then it fills with green, which is 02550, and then jumps all the way down to the circle line. Finally, if neither of those two things earlier were true, it then fills in with blue, and then it exits and goes to the circle line. Logical expressions help us do these things in a slightly different fashion. They're also somewhat unintuitive sometimes because they're syntactically a little bit different from how people use the words and or and not. Computers have a very strict idea of what those words mean. So for some examples, the statement programming is fun and programming is useful is true because because programming is fun is true and programming is useful is true. On the other hand, the statement at 22 degrees Celsius water is a liquid and water is a solid is false because only one of those things can be true at 22 degrees Celsius or at most temperatures. So in specific, water is not a solid at 22 degrees Celsius. But the statement at 22 degrees Celsius water is a liquid or water is a solid is true. So computers have this very sometimes irritating idea of what or statements mean. So if one or the other is true, then the whole thing is true. A computer, if you asked it if it wants a banana or an apple, if it wants either one, would say yes. It will never answer you banana or apple. If you ask, do you want a banana or an apple? Okay, so that's our review. We now have an on-screen example. I will again fade myself out. So you can see here we set up a few logical conditions that we have right up at the top. We have top is equal to mouse X is less than 500. That corresponds to us being in the top half of the screen. Bottom is mouse Y greater than 500, which corresponds to us being in the bottom half of the screen. Similarly, right is mouse X greater than 500. Left is mouse X less than 500. That's all fairly straightforward. The interesting bit is what we do with it. So we then say that if we are in the top section and we're in the left section, we want to fill with red. Right? But if we are in the bottom section and the right section, we want to fill with green. Otherwise, if we're not in the top left or the bottom right sections, then we want to fill with blue. And you can see that when you look at the animation. In the top left and bottom right sections, we are not blue, we're red and green respectively, but in the bottom left and top right sections, we're blue. Similarly, for the shapes, we say if we're in the right section and we're not in the bottom section, which is corresponds to the top section, but not bottom, is just an example that it's one of the best examples we could come up with. then we want to draw a square. And so you can see in the top right section, we draw a square. Everywhere else, we draw a circle. So there's one other special variable that we wanted to mention before we get too much further into this. It's a Boolean variable called MOUSEPRESSED. So if you recall, Boolean variables are either true or false. So if you are currently pressing down on the mouse button, then the variable MOUSEPRESSED is true. If you are not currently pressing down on the mouse button, MOUSEPRESSED is false. And it's a very useful thing to use when combined with if statements in your draw function. So that's if mouse pressed, print the mouse is pressed now. You could also use it to turn on or off, collisions, or change the shape that you're drawing, etc. All of those things are very useful. Okay, we now are going to have you guys do an exercise. We just want you to make a circle that moves to the right of the screen. Starts moving to the right of the screen and bounces. So it should change directions when it hits either edge of the window. I'm going to turn off my video and audio and give you guys a couple minutes to work on that. And I will be back shortly. Okay. Uh, normally we like to give you at least 5 or so minutes to work on these, but today we're going to just move through that a little bit quicker because this is sort of the review portion of our section. And if you have any questions, you can feel free to go watch Jed's video where he goes through this style of exercise in a lot more detail. That should be posted as well. But we're going to continue. Oh, also have that one, but we're going to skip past it. Okay, so we're going to talk about lists. So lists in Python, if you ever go looking for information on lists, list is the word you want, but if you look for it in other programming languages, the word is going to be array. They're slightly different, but that's what you're looking for. So lists hold multiple values, which is very useful oftentimes for storing a list of the same sort of thing in one kind of with one name. So it lets you create a whole bunch of similar variables at the same time and mostly type less, which is very convenient. As I believe I've mentioned, a lot of programming is figuring out how to type less. So that's kind of the idea behind lists. So this is our list syntax. So these square brackets tells the computer that we want to make a list variable. So lists can hold any kind of data. So they can hold numbers, they can hold strings, they can hold booleans, anything else, which we will get to what else there can be. They can also hold those, which actually includes lists. You can create a list of lists, or a list of lists, etc. And that does tend to be where things start getting very complicated. But by and large, if you know what you're doing, you can do some really powerful stuff with lists. Oops. I am just going to switch us over to processing. And I'm going to just copy over some of the things that we had from over there. So we have random numbers, and we'll make a new array using square brackets. So we have 101, -2, 303, 44. You may notice those are not the most random of random numbers, but that's just going to be what we're dealing with in terms of pseudo-randomness today. We'll make another one. We'll make it an array called students. So we have Henry, we have Alice, we have Jack, and we have Alex. I've forgotten the end quotes on Jack there. Okay, and now if we do a setup, and we just try and print this list, let's see what processing does for us. So you can see processing printed the list right here in the console. It also made a sketch in the background, but that's not super important. Okay, if we print students, then we'll see something similar. We'll just do that very quick here. And you can see it printed out our array, our list of strings with student names. But thus far we can't really access any particular number. That's what we're doing now. So what we want to do is we want to start accessing the individual data within a list using an index. So using the numbers array from before, we would access the elements using the indices over at the right. And I will turn off my camera again real quick just so that we can see the whole table. So the main thing to note is that lists start with an index of 0. So the first element is index 0. Kind of one of the easy ways to think about it is how many numbers do you need to skip over to get to this one, right? So if we wanted to access the first element, oops. Yeah. If we want to access the first element, then we don't need to skip over any items. We just look at the first item. If we want to access the second element, then we need to skip over this first one. So we use the index 1. If we want to access the third element, then we need to skip over 2, so we need an index of 2. The reason that it is this way is some complicated computer nonsense that dates back to approximately 1980. Some languages do this in a different way that's more human readable, but most languages stick with this convention because it's actually very useful for a lot of math as well, which you'll see if you look at some of the advanced examples for this week. At least one of them uses some math to figure out where we are in a list that is harder to do if you do it in a fashion where the first index is 1. Not a lot harder, just a little bit more irritating. So let's switch back to processing. So if we want to access the third element, right, the third one, so let's say we want to print Jack from students. We use the index 2 because we need to skip over Henry and Alice in order to get to Jack. And so we see if we print that, then it prints Jack right down here. I do promise we will get to some interesting stuff using lists in just a moment. But this is kind of the standard intro to them, and we wanted to make sure that you had that as well. Okay, again, we have me in the way, so I'll turn myself off for a moment. Okay, so we can also change our list over time. So if we start with an empty list by using just an open and a close bracket, as we have there, then we can add items to the end of the list by using this kind of keyword .append. And so we use that. It's called a method of the list. We'll get into what that means at some point in the future. But for the moment, we're just appending to the list. Okay? So if I switch us back over here, and if we make a shopping list, which is an empty array, just using the open and close brackets there. We do shopping list dot append eggs, shopping list dot append ham, shopping list dot append cheese, and shopping list dot append onions. Now, this is a fairly contrived example. You wouldn't typically create an empty list and then immediately add 4 things to it. You would typically create the list with those 4 things in it. But you might end up with a program, for example, if you were trying to draw a bunch of enemies on screen, then what you might do is whenever a new enemy appeared is add it to the list of enemies. And then once you've done that, you then just go through the list and draw each of the enemies. And we'll go over how you do that in just a moment. But for the moment, this kind of example of what append does is going to be useful for us. So we're also just going to quickly print our shopping list so that we can see what we ended up with. So you can see that what we do every time we append is it adds it right to the end of the list. So eggs was added first, so it's the first element with index 0. Ham was added second, so it's the second element with index 1. Cheese was added next, so it is the third element with index 2. And onions was added last, so it is the fourth element with index 3. So we also can check the length of our lists fairly easily. So again, this is more useful when you're changing your lists on a regular-ish basis. If you just kind of create it once and then never touch it again, then you can just have a variable that holds on to that. But if, for example, you had something like in a list of the enemies that you were drawing, then having the length of the list and being able to get that fairly easily is important. So in this case, the way that we do that is using len, so L-E-N, like the first few letters of length. So we will quickly demo that as well. If we print the length of the shopping list, this will print for us 4, because there's 4 elements in the array. If we do that before we append anything, we should see the value 0, which we do right up here. So you see we create shopping list, we then ask the computer to print its length. There's nothing in it, so it prints 0. Then we append 4 items, print the shopping list, and print its new length, and that new length is 4. So using lists is pretty much exactly the same as using other variables. If you want to give it a new value, then you can do you assign it just using it on the left side of the assignment operator. You can use it as a variable for substituting in for drawing things. You can use it to change other variables, so you can update it. All of the stuff that we've been working on previously, all of the stuff we've been using variables for before, you can do that also with lists. And the only thing to note is that when you need to access a new or a specific element, you need to use the correct index. So let's pull this up. So what we'll do is we'll make a new array. So we'll say sizes is equal to 30, 46. Def draw. I wanted to change it, so global sizes. So then if we draw a circle at 100, 100, sizes 0, right? So that's going to access the first element because we need to skip over 0 elements to get to that one. So it's going to use 30. I'm not sure if you've seen it, if we've done it in slides before. Circle is a very simple function that just draws an ellipse with the same width and height, and that's whatever this last number is. So in this case, that size is 0. We can also, why don't we actually just update our size. So we'll say sizes at 1, whoops, sizes at 0 is going to be equal to, we'll use actually our increment operator, plus equals. So we're going to add sizes at 2. So this circle is going to get very large very fast. So hopefully my capture is set up correctly. I also do need to add a couple of lines here that are specifically for my streaming setup. You don't need to worry about what these lines mean, but if you are curious, we will eventually post a video that talks about what these mean. And I need to do set. So I think you just caught the tail end of that there. Let me see if I can run that again. So this is one of the technical issues we were running into last week that I thought I had fixed, but evidently not. My apologies to all of you on that. But again, I do hope that we will be able to find something to fix that. I'm just going to switch us back to processing. Yeah, one of the problems that we encountered last week that I thought I had fixed, but apparently not, is that it is difficult to get our software to appropriately capture windows that close on occasion. So again, I will look into that, and we will hopefully have that fixed for the next session, but you all have my apologies for not having that ready this time around. In any case, if you ran that code, what you would see is a circle that very, very quickly grew and grew and grew because we just used one array element to update, sorry, one list element to update another list element. And we used that first list element to draw the size of our circle. Okay, so here is going to be your exercise. So we would like you to use lists to draw 4 balls that will all move down the screen at different speeds. The best way to do this is to actually use 2 different lists. One of them you should use the list, one of them should store the ball speed, one of them should store the ball's positions. So again, I will turn off my video and my audio, and I'll be back to you in about 5 minutes. Okay, we've had about 5 minutes to work on this one. We should have all of the code for these various examples posted somewhere at some point. We will keep you posted on that. In case you didn't get to finishing this one, I do believe we also have some stuff for the advanced exercises at the end that will be quite useful in figuring out how to do this. So, with that said, we are going to move on here. Sorry, just needed to fix something on my setup. And we're going to talk about loops. We're going to talk about some basic loops. We're not going to get super complicated with it. But we do want to talk about some loops. So loops repeat the same code with possibly just some small thing changed over and over and over again. So they will run actually indefinitely. And I see that we're missing the bottom right corner there. So I will turn myself off once more. There we go. Today we're going to be talking about the most common type of loop in this kind of programming, which is a for loop. But it is worth mentioning that draw, the function draw that we define, that kind of works like a loop, right? So every time we reach the end of it, we just start over and go again, right? And while things are allowed to change, we just run the same code over and over and over again, right? So that's one kind of loop. The kind of loop that we're talking about right now runs on a specific number of iterations. So loops can repeat code for lists, and this is why we talked about these in the same session, because they're really, really useful when you put them together. So this code that we have on screen, using our same kind of shopping list example, what this will do is for every item in the shopping list, it will put that item into the variable item, and then it'll print it. And this is a very simple example, but if we switch over to processing here for a moment, I'm going to get rid of this section here. We still have our shopping list from earlier. This is all the same. And what we're going to do is just say for item in shopping list. And the important bits of the syntax here are for. This tells the computer that we want to start a loop. Item is what our kind of the items that we're working with, the elements that we're looking at, that's going to be its variable name. In is an important word here, so you need to make sure that there's the correct spaces on all of these parts. And then shopping list is the list that we want to iterate over, and then we do need to end this line with a colon as well, similar to if statements. So for item in shopping list, we want to print the item. This is fairly simple, but you can see right down here, after all the stuff that we printed earlier, we print eggs, ham, cheese, and onions. And so it's worth paying attention to the fact that this does run in order on these things. So it runs eggs, then ham, then cheese, then onions. Another example on what you can do with this sort of thing is a dartboard. So if we have a bunch of different diameters in a list, we can iterate over these diameters to draw a bunch of nested circles. So let's actually switch back over to processing very quick here. So we'll set that up as well. So we will say circles equals 200, 175, 150, 125, 100, 75, 50, and 25. So this is our new list of diameters. And we're going to say for diameter in circles. So you can see the list that I'm iterating over, the list that I'm looping over, sorry, is circles. you can see that the variable that I'm using to refer to each item in the list is called diameter. This is the same syntax as before. It doesn't really matter what you call things. Similarly to variable names, most of the time it doesn't really matter what the name is. It just matters that you have everything set up right. So in here, if we want to do all white, we can do circle 150, 150. That's our position, X and Y. That keeps us centered. And then we can do diameter. This actually needs to be in draw, so my apologies on that. Def draw. There we go. Okay, I will switch us over to my sketch window. Just a second here. So you can see our dartboard right up there in the top left corner. So if we wanted to make that a different color, we could add a second list of colors. So we could say our new red values, our new green values, our new blue values. But it's a little bit tricky at this point to make sure that we're at the same spot in each of these lists. So while we will eventually introduce some stuff to let you deal with that, for the moment, just to give this a bit more visual interest, I am going to fill it with a random color. Which would actually work a lot better. Nah, that was impromptu. I'm not going to do that just because I don't feel like having a seizure or giving anyone with epilepsy a seizure. So we will pass on that. But you can also set that up with different colors. It'll just be a little bit tricky to deal with. We can make it just different shades of gray by doing something like fill, diameter, diameter, diameter. So remember, if you fill with a color where all of the numbers are the same, that's going to be a shade of gray. So if we run this one, what we end up with is, one quick second, that's interesting. I see. Sorry, I've just managed to screw up my setup. There we go. There we go. So you can see with this, what we end up drawing is a bunch of circles with different shades of gray that increase as we go towards, that get darker, rather, as we go towards the middle, because 0, 0, 0 is black, and the outside is 200, 200, 200, which is fairly close to white. It's also, by happy coincidence, fairly close to our background color. We could change that, but I'm not going to do that right now. Okay. So that's a very simple example of the sort of stuff you can do drawing using lists. But we would like you to work on this exercise here. So this is a bar graph race. So we would like you to make 10 rectangles that grow bigger over time. If you can manage it, making them change colors would also be very interesting to see. So I will again leave you for a couple minutes. Please have a go at this. And if you have any questions, please do post them in the Discord chat. Okay, that's more or less the end of the content we have for today. We actually, despite starting a bit late, we actually ended up going through this fairly quickly. So, if any of you do have any questions, please do feel free to post those in the Discord server. Um, but aside from that, pretty much all we have for you for the rest of this session is our challenge examples for the week. Again, you're free to continue working on whatever you were doing. I physically can't stop you. You're all in your own homes, hopefully. Um, but we do recommend that if you kind of have a good understanding of everything that we talked about today, that you have a look at trying to do one or both of these examples that we have here on screen. Um, the I'll actually go through the code for this brick breaker example on the left in a little bit for anyone who is interested. The code on the right is a very useful thing to have a look at for all of the bouncing ball demos that we talked about, and I believe I'm not positive, I haven't actually watched the video yet, but a useful resource on how you might do that is Jed's 17-minute video posted just a little bit ago. So if you are interested in doing that thing on the right, please go have a look at that. The example on the left is based very heavily off of off of the code that was written for last week's, or for session 3, that did sort of Pong style thing. So it uses the paddles to do to collide with the ball, and then we have a bunch of blocks over on the right side that can be broken. But by and large, that's all we have for you today. In about 5 minutes or so, I will go over this brick breaker example. I'll go over the code for that. Very kind of, I won't go super in depth on it in case anyone is still interested in doing that themselves. If you are interested and don't want spoilers on how I did that, then feel free to tune out. That's all we have for you this week. So please do feel free to check out Jed's video explaining the Pong examples from last week. If you have any feedback on how this session went that you would like to give me, you can either post that in the YouTube chat or in the Discord server. Yeah. So thank you all very much for coming and attending this week's session. We do appreciate, again, your patience with the technical issues that we're facing and with kind of the whole situation. So, yeah, thank you all very much for coming, and that's pretty much all I have for you today. And like I said, I'll turn myself off for another couple minutes, and then in a couple minutes I will go through the code for this challenge example on the left. I might give you a short demo of it running first. Okay, so for those of you who stuck around, I am now going to go through the brick breaker code. I will just quickly, oh my goodness, I'm just quickly going to show you the code running. So if I switch over to the sketch, there we go. So you can see here, this is a fairly simple kind of brick breaker application. It's very heavily based off of the one of the pieces of Pong code that we had for last week. So if you haven't watched Jed's video and you haven't looked at that code, I do recommend doing at least one of those things before having a look at this thing. This is also going to be more impromptu than the session as a whole, which you may find difficult to believe, but I didn't actually prepare to present this today, so this is going to be slightly less polished. That said, this is the game as it is running. You can see there's actually a lot more rows of blocks in here than there is on the GIF, and if you download the code for this, you'll actually see a slightly different version to what I have uploaded. I will update that shortly after I go off the air. Wrong word, but shortly after I'm not live, I will update the code to the most recent version. But what I'm going to do is go over this most recent version and talk to you about how it works. So, one second, that's gotten us the wrong thing. Hold on. There we go. Okay. So we're now looking at the sketch. Most of this is going to be fairly similar to the Pong examples, so I'm not going to go too heavily into the details of that, but let's go over this. So starting in setup, we're just going to set up a bunch of global variables. So these are global variables for the ball's current position, its radius, and its velocity. Its radius doesn't change, so I could have just used a number, but there's a concept in programming called abstraction, which is where pretty much if you can make it a variable or you can pull it out of, sorry, this is refactoring, not abstraction. If you can make it a variable or you can pull it out of a separate block of code, it's a good idea to do so. For example, in this case, if I want to change the ball's radius, I only need to do that in one spot instead of everywhere. You will also notice that instead of having a ball, we have a block, and that's because I couldn't make collisions look not weird using a ball. We then also have some global variables for the paddle, which includes its x and y coordinates and its height and width. Again, most of these don't strictly need to be variables, they could just be numbers. But again, if we have a lot of these, if we use this in a lot of different spots, then it's really useful to only be able to change it in every spot by changing it in only one spot. Then finally we get to some new stuff. This is for the bricks. So this global bricks intact, that's going to be the array that stores whether each brick is currently intact, whether we've hit it and broken it or not. Then we have a variable for brick width and a variable for brick rows. We also will have a local variable for brick columns. Rows is the only one that needs to be global to do some weird math in order to make sure things work out correctly. Okay, setting up our size, fairly straightforward. Initialize our ball to the center of the screen with a specific radius, moving to the right and not up or down at all. Similarly, initialize our paddle to a specific position and height with a specific height and width. That's all fairly straightforward. Now we get into some stuff that's a little bit more complicated. I will upload this fully commented as well. It's partially commented, but I will make sure that it's fully commented when I upload it. Okay, so here's what we have. We initialize bricks intact to be an empty array. And what that does for us is it means that we can add as many bricks as we want. So we then set our brick width. This also doesn't change. It's just convenient to have it in one spot so that if I want to, I can change it everywhere that it's used while only changing it in one spot in code. Then we have some variables corresponding to the number of rows and the number of columns of bricks that we want. So in this case, I've set it to 6 and 6. Brick and rows is global. Brick and calls is not global. That one's only used in setup. Okay. Now, the thing that I'm doing here is I'm saying for this is a keyword that we didn't go over in class. What this does is it just it acts like an array of every number from 0 to whatever this number is, not including this number. So in this case, it'll be an array of 1 to 6 times 6, which is 36 minus 1. So 0 to 35, and there's 36 numbers in that array in total. So we didn't go over this because it's not, so in Python, this isn't the general way that one does arrays, but I couldn't come up with a better way to do this one. So bricks intact append true. So every time we're going to go through and we're going to append a true value to the end of bricks intact. And we're going to do that a total of, in this case, 36 times, but in general, brick and rows times brick and columns times. And that gives us one big long array that has as many entries as we have bricks. Note that what we have in that list is just a big long kind of list. It's just linear. So the fancy math that we need to do later is to figure out which position it's in. Excuse me. This bit of code we can actually remove. That was for an earlier version. Then we have again these two lines that you don't really need to understand. They're just they're necessary for my streaming setup. Okay, then inside draw we go grab all of our global variables. You can move all of these onto one line, but I like to list them out just so it's very clear what I'm using. We set our background to 0, fill 255, and no stroke. So this math is all fairly similar to the Pong math. I do recommend that you go check out Jed's video on that because I do believe he talks about it. So I'm not going to talk about it in too much detail. If it turns out after I watch the video later that he doesn't actually talk about this, I'm going to be somewhat embarrassed, and I'll talk about it at some point in the future. Not my embarrassment, the code. But yeah, this puts our this has our paddle tracker mouse. Make sure the ball is on screen vertically, and then we do a bunch of stuff to figure out where the ball should go next. So the only stuff that's different between the Pong code and this code is this last else condition, and this is to figure out if the ball is going to hit a brick. And what I've done to simplify things is said that on each frame the ball can only hit one brick. It goes through them in an order and checks each one, and then as soon as it finds one that it hits, it doesn't let it collide with any others that frame. So we start with a variable call that's counting our current column, a variable row that counts our current row. We also set up this variable hit brick equals false, and so what that does is it keeps track of whether or not we've hit a brick this frame. Okay, so then for brick in bricks intact, so this is going to iterate over all of the true or false values that we have in our bricks intact array list, not array, list. So when we start up the program, they will all be true, and we'll have a number equal to the number of rows times the number of columns, so in this case 36. Then if this brick is currently intact, which we write using if brick, I could have called it brick intact and that might have been a bit clearer, but this particular brick, this true false value is stored in brick when we iterate over. So if this brick is intact and we haven't yet hit a brick this frame, then we do a bunch of stuff to check whether or not we hit the brick. And this is all very similar to the collision code from Pong. Again, I do recommend that you check that out. The only things really that we need to note on this in particular is that we do need to calculate our index, and this is where our math comes in a little bit. So what we do is we iterate over all of our rows and then over all of our columns. So our index is going to be our row plus our column times the number of rows there are. So I'm actually going to pull up the example. I'm going to run this again and then just kind of explain what I mean by that. One second. Okay, so I'm not going to pay attention to the ball. I'm sorry if that bothers anyone, but I'm just going to talk about the bricks right now. So what we do when we're drawing these is we start at the top right corner and then we go down. So this is brick 0, this is brick 1, this is brick 2, 3, 4, 5, 6. Okay? So the thing to note is that these ones at the top all have an index that's a multiple of 6. So we have 0, 1, 2, 3, 4, 5, 6, because we've skipped over 6 bricks to get here. 7, 8, 9, 10, 11, 12, because we've skipped over 12 bricks, right? So this is kind of why it's nice to think about the what's called zero indexing. So when our arrays start at 0, we can do this kind of math very nicely. And what this lets us do is, if we keep track of our row, or our column, sorry, then we know that we're going to be between that column times 6 and that column times 6 plus 5, right? So for column 0, we are in column 0 here, so we're between 6 times 0 and 6 times 0 plus 5, which is 5. So we have 0, 1, 2, 3, 4, 5. Okay? That's fairly complicated idea. If you do have any questions about that, you can feel free to either have a look at the code or talk to your mentors, please. I'm sure they'd be happy to talk to you about it. Okay, going to transition us back. So that's what that's doing. If you trust me on that line finding the correct brick index, I'm also going to turn off the game in the bottom left corner of my screen because that's very distracting. So if you trust me that that determines the correct index, then what this does here is it says for that index, the index of the brick we just hit, set the value to false. And so what that means is that we've now hit this brick, so we also note that here, brick equals false. And then we do a bouncing thing, and we also denote that we've hit a brick. And so what this does is it makes sure that we don't hit multiple bricks in the same kind of frame. We don't hit multiple bricks in the same frame. Yeah. That's by and large all that happens in here. Here's the iterator code. So this says we want to increment our row, and then if our row is greater than the number of rows, greater than or equal to, because we start counting from 0, then we want to move to the next column and reset our row to 0. Some more stuff that comes straight from the Pong example. Similarly, this is also a line that we haven't gone over in sessions. It's rect mode. I used it just for convenience. You don't really need to use it, but what this does is it just changes how processing draws rectangles. So rect mode center means that instead of using the top left corner for the rectangle, it uses the middle of the rectangle. Everything else is the same. Rect mode corner is the default. That's just how it behaves normally. And then for each brick, we want to draw the brick. Again, there's some stuff that we haven't done in class. I will remove this before I put it up. But what this does is it just sets it up to draw in the mode called corners, which is where instead of specifying the top left corner, the width and the height, you specify the top left corner and the bottom right corner. And you can see that's exactly what I've done. I say brick left, brick top, brick right, brick bottom. And these calculations, excuse me, are fairly straightforward as well, just determining where the right and left and top and bottom of each brick is. And again, we just need to keep track of it. And then I have a mouse clicked thing. You don't need to worry about that. That's just because when I'm streaming, it takes me a little while to switch back to the processing window after I start the sketch. So I just put in a thing to let me reset the sketch to its initial state. But that's it. That's all that goes on in here. I know I skipped over a lot of code. That was intentional. I do want you all to go watch Jed's video talking about the Pong example. I've now put a lot of weight on that, so if you're watching Jed, I do apologize for pushing so much explanation onto your video that you weren't expecting to be explaining this. And again, if Jed's video doesn't go over something that is important to this example, I will go over that in the future. Probably just after next session, something like that. But that is for real all that I have for you today. And I'm going to sign off in just a minute here. Again, thank you all for watching. Thank you for sticking around to watch this explanation of the more advanced code. I will make sure this is uploaded with comments and without all of the confusing stuff. And yep, that's it. Thank you all for watching.